I'm Anil Kumar. Welcome to my series on graph. In this video, we will understand how to read information from speed-time graph and use this graph to find acceleration and distance. The question for us is, for the following speed-time graph, describe the motion of the object, sketch a possible acceleration time graph, sketch a possible distance time graph. So let's begin with describing the motion of the object. So we are assuming that the object starts from position O, that is the initial point. So that is the path which is being followed. So let me just make it bolder. So these are straight lines. So initially, we have this velocity versus time graph, right? So we have velocity here. So what we notice here is that the velocity increases at a constant rate. Here, the velocity is constant. Then again, the velocity is increasing. And in this portion, velocity is decreasing, correct? So rate of change of velocity is acceleration. So let's be very clear about it. So what we see here is rate of change of velocity is acceleration, right? We need to draw a possible graph of acceleration and time also. So let's calculate acceleration. So let me say this point is A for us. This is B. Here we have C and then D, right? So from 0 to A, the acceleration will be how much? So we'll call it acceleration from 0 to A is equal to rate of change is the slope. So it rises by 2 units, which is 2 meters per second, and it goes, time taken is 4 seconds, right? So it is half meters per second square, right? Now from A to B, acceleration from A to B is basically 0, since the change in velocity is 0, right? And it takes a time period of 2, so it is 0 meters per second square. From B to C, we can see that the acceleration from B to C is change in velocity is from 8 minus 2. Let me write 8 minus 2 here. As far as time is concerned, is 8 minus 6, which is 6 over 2 or 3 meters per second square. And then from C to D, the acceleration is negative, right? Since the velocity is decreasing. And it will be at D, it is 4 minus 8 over 12 minus 8. So 4 minus 8 is minus 4, 12 minus 8 is plus 4. So we have minus 1 meters per second square. So from here, we can describe the motion of the object. So to describe the motion of the object, let's say, we can say that the body starts from rest, accelerates at a constant rate of half meters per second for 4 seconds, right? So we can say the body starts from rest at increasing velocity, accelerating at the rate of half meter per second square for the first 4 seconds, right? 4 seconds, correct? And after that, it moves with a constant speed of 2 meters per second, right? Then moves with constant speed, no acceleration, right, of 2 meters per second for 2 seconds. And then it accelerates, right? So at this interval, it accelerates at 3 meters per second, right? Then object accelerates at 3 meters per second square for 2 seconds. 2 seconds, right? And then the velocity drops, right? Now it is still positive, but it's dropping, correct? So the object is still going further away. Distance is increasing. Object continues to move forward at deceleration. So that negative of 1 meters per second square, right? So deceleration is minus taken care by the word deceleration itself. So overall the distance is always increasing. However, the acceleration increases, becomes 0, much higher, and then negative. So that is how you could describe it. Now, we have already calculated the acceleration. We can draw it on this particular graph. So let me draw acceleration and time graph. So the units for acceleration is meters per second square, and we have negative also. So we'll have a scale which will be, since we are going down here, what I will do here is make a new scale. Since this part is not very clear to you, anyway, we can go on the same scale. Okay. We'll use the same time scale. And as far as the y-axis is concerned, we'll say now the units are in acceleration in meters per second square. Is that clear to you? So this color we'll use for accelerations in meters square, meters per centimeter square. In the first 4 seconds, it is half. So it will be very close to this. This is 1, that is half. So the acceleration is like this. Do you see that part? So that is the acceleration in the first 4 seconds. And then it is 0. So then we'll draw along the time axis. And then it is 3 meters per second square. So after this, it is 3 meters per second square, which is here for a duration of 2 seconds, correct? And then it is negative 1. So negative 1 will be from here to there. So that will be negative 1, right? So that means negative 1. Is that clear to you? So that is how we are going to plot the acceleration on this particular graph. Okay. Now in the next graph, we will see how to draw the distance time graph from the given velocity time graph. In this video, we will understand how to sketch a distance time graph from given velocity time graph. So we are given velocity time graph here. We'll now sketch distance time graph from this particular given graph. Now distance is basically calculated by finding area under the velocity time graph, right? So we know distance is area under velocity time graph. Right, so that is kind of important thing to understand. So we get actually value of a distance from this. Second important thing to understand is the shape. So now that is kind of important, and we'll actually look into the shape of distance time graph also while sketching. Now, if the velocity is increasing, in that case, distance time graph will be kind of like this, right? So that means distance is increasing fast. So in this particular case, we see that the velocity is increasing at a constant rate. So distance will be kind of like this. Now in the next section, distance is constant, but the velocity is constant. So distance is increasing at a constant rate. So then it will be kind of a straight line, right? After that, we find that the distance increases and the velocity increases steeply. There's acceleration, positive acceleration. So in this duration, the distance will go up very steep, a non-linear graph. At the end of this peak, we find that the velocity drops. There is deceleration. Distance still is increasing since the velocity is positive. So in the later half, distance is going to be kind of like this. So that is how the shape of distance time graph is going to be, right? So when there is an acceleration, right? So if there is a positive acceleration, in that case, the distance time graph will have a parabolic path like this. And here, the acceleration is 0, right? And at the end, it is like dropping down if the acceleration is negative. Now, this is very important to take care of while you're discussing how to sketch distance time graph from velocity time graph. Okay, now let's work out the values, right? So we'll try to figure out the values of distance covered at different critical points. So that is a critical point. Then again, we have a critical point at time 6 seconds, then at 8 seconds, and then at 12 seconds. Let's call them as A, B, C, D. We are starting with initial point. We'll assume this to be 0. Okay. Since we know that distance is area under the curve, so the distance between O to D, so distance at A will be how much? So at this point, it will be the area under this curve. So the area under this curve is half of base of 4 units, which is seconds for us, and 2 meters, right? So times 2, which gives us a distance of 4 meters. So it's going to be 4 meters. Now from A to D, we'll add from A to D, right? So we are now saying up to D. From A to D, we add an area which is equal to these 4 squares, right? So it is 2 by 2. So basically it is 2 by 2. So we are adding 4 units. Then from A to B, and then from B to C, we are again adding a distance, and that is the area. Now this time you will note that we form a trapezoid. So this trapezoid area is half of length of these two parallel sides, which is 2 plus 8 times the distance between them, which is 2 units, right? So that is the formula for trapezoid area. So that gives you 2 and 2 cancels, we get 10 meters. And now let us calculate the distance which it increases from C to D. C to D is also a trapezoid, so that will be half of parallel sides 8 plus this is 4 times distance between them of 4 units. So that means 8 plus 4 is 12 times 2, 24 meters. So from here we know that the cumulative distance, let's find the cumulative distance. That is, at A the distance is, let me write down sum of distance or cumulative distance, right? So it is 4 meters, and then we add 4 and 4, these two, it becomes 8 meters, and then this, it becomes 10 more, 18 meters, and then all of them add 24 to 18, 4 and 8 is 12 to 1, so it becomes 42 meters, correct? So total distance is 42 meters. So in our scale, we'll have now distance in meters on the vertical axis. We want that to be 42 meters. We have 1, 2, 8, 9, 10, 12, right? So we can go by 4 units, correct? So if I go by 4 units, then this becomes 8, that is 16, 24, 32, 36, and 48, right? So let this be the distance for us. Now we'll sketch the graph. We know the ultimate points. At the end of A, it is 4 meters. So as per the scale, we have to reach here. Here we have an acceleration, and therefore the curve will be kind of curved, right? So it increases rapidly. So it will not be a straight line, but a curve kind of like this. Do you see that? Now from A to B, we cover another 4 meters, and that makes the final distance to 8 units. So we have to reach at this 8 units, but this will be a straight line. Do you see that? Since the velocity is constant, there is no acceleration during this period. And then at C, we have covered a distance of 18 meters by now. So 18 meters is, we have 4 units, so 16 plus 2. So around this point. Now this has been done with a great speed. Acceleration is high, so it's a curved surface, right? Do you see that curve? And now from C to D, we have covered a distance which is 24 meters. Ultimately, a point is reached which is 42 meters away from the origin. So 36 and 4 is 40, and then each unit is 4, right? So we have 42 around here, right? So, and that is, curve has to be like this since there is deceleration at this time, right? You see the shape of the curve. So as you can see here, this particular shape indicates that velocity is decreasing. Right? Now here, this shape here, in this portion, velocity increasing. It's a nonlinear graph increasing rapidly. In this straight line, we have constant velocity. Perfect. So that makes a huge difference when you sketch. So when you're sketching distance time graph, it is kind of important to understand that these are not all straight lines. Only straight line will be when velocity is constant. Then distance is increasing at a constant rate. I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.